Now let's create model. So we will be creating different models here. First model, it is directly on the whole data frame. The second model that we will be building, it will be after splitting the data into test and training data set. And third will be after checking the variables, which one is significant, which is not, and keeping only those variables that are significant. So first, let's build a model on all the independent variables and whole data set. So when we want to create a model, we use the function glm. Inside that, inside the bracket, the first thing we mention is the dependent variable. In our case, it is the admit, that is the factor which will tell you whether the student is selected or not, that we are predicting. All the independent variables, then the name of the data frame and family. So if you want to know what is family here, what does it describe, you can always get help from R by questioning in glm, and you will get a help here. You will get the whole formula and description of that formula. So we are checking family here. So family is a description of errors, error distribution and link function to be used in the model. For glm, this can be a character string naming a family function, resulting to call a family function. Let's see what are the different families that we can take. So family objects provide a convenient way to specify the details of the model used by the function glm. So some of the models functions that we can use is binomial, gamma, Poisson. It depends upon the type of data you are using. For now, as we are using a normal data frame and making a logical relationship, so for that we are using a binomial family function here. So let's execute the command and create the data. So let's execute the command and checking the summary of the model. So as discussed earlier, there are several elements that we need to understand when we are understanding the summary of the model. So first are the variables that we are keeping for our model, p-values and the significance code and EIC value. So first, the variables that we used are GRA, GPA and rank. So you can see there were 4 ranks and we converted them to the factor data type. So every rank became a category here, and the significance code here, they can tell you how significant a variable is in our model. So rank 3 and rank 4 is the most significant variable, and other variables GRA, GP and rank 2 are less significant, but still they are significant for the prediction of model. And the AIC of this model is 470.5. So let's create one more model wherein we will be distributing the data into training and test data set, and let's check if there is any change in the AIC value of this model, and also if there is any change in the significance of the variables. So for dividing the data set into training and test, what we will be doing is using sample command. For that, first we will save all the rows of my data into a new variable, that is n, and after that I'll be using sample command and dividing the whole data set, that whole rows into a 70 into 30% of ratio. For that, the command is from first taking all the rows for 1 to n, that is 1 to the last number of this row, that here it is 400 rows. So 1 to 400, and that is n. And then we will give the size. So we are giving 70% of the whole data. And replace, we are taking it false because we want each and every record of this data set to be used. So we are not replacing any of the record for our 70% or 30% data. So let's execute this command. Now we are subsetting the data set, the whole my data set. So the first variable is train, that is for the training data set on which we will be building our model, and next variable will be for test, in which we will be predicting our values from the model we will be building. So for training data set, from the whole data, that is the name of my data frame, for subsetting, I am using bracket notations, and within brackets I am specifying the list of rows that are saved in sample variable here, that are the 70% of the whole data set. Next, it is the test. So except the rows that are saved in training, rest will be saved in test dataset. I'm using a minus sign with sample here to eliminate all the rows that are saved in training dataset. Now that I have created, divided and created different data sets for our model, we will be building a second model. So I am saving the model in log R1, again using the function glm. This time I will be using dataset as train and execute the command. So let's check the summary of this model. Now you can see the AIC of the whole model has decreased, which means it is a better way to create a model. As we know, lesser the AIC, the better the model it will be. Now let's check the variables that we want to keep in our model or not. So here you can see GRE, it has become more significant, and rank 4 and rank 3 are also significant. Even rank 2 is significant because you can see there is dot here, which means it is a slightly significant variable. But GPA here, which is a insignificant factor, because the value of P here is more than 0.05, which is very, the value is very high here, 0.38. So we will be removing this value and will again build a model to get a significant prediction. Before that, what we can do is, as we have created a model here, let's also check the accuracy of this model and predict the values if this model gives us a better prediction, or if after removing a variable there will be better prediction. So for predicting, the command that will be used is predict. The command that is used for prediction is predict. I am saving those variables in predicted. Within the function predict, the first thing we mention is the model of the model that I have saved in log R1. So it is the model that I have created on training data set. Next, we will be mentioning new data. So new data here is the test data set that we have created. So what we have done is we are building a model on training data set and predicting it with test data set. And type here is response. So what is response? Let's again get help from R, and you can see what is predict whole tells you. So here you can see if you check predict, there is help, but there is a general help that we are getting. Below you can see there is predict.glm that we want here. So let's click it, and here is the formula that you will be using for predict. The most needed objects in this are first the data, the model that we created, the data frame that we are using, and then the type. So type can be of link, response, and terms. So how do we decide which to select? Here is the details for that. The type of prediction required. The default is on the scale of linear prediction. The alternative response is on the scale of response variable. Thus, the default binomial model and the detailed prediction are of log odds. So they are probabilities. Response gives the prediction probability. So what we want is, we want our response to be in the form of prediction, in the form of probabilities. So therefore we are taking response as a data type here, as a type for our prediction here. So we have executed the command. Now if you check the values of response prediction, so my variable is predicted. I'm printing the values. There are many values, so let's check the first 6 values. For that I'm using head command. So you can see it is a very high number with many decimal points. For that, what we will do is, and we know that actual admit, the selection process, we were having a binary levels, that is 0 and 1. So we will be using the formula here, if else, wherein the predicted values, if they are greater than 0.5, it will print 0, otherwise it will print 1 to our predicted values. And I'm saving it in predict v variable, and I'm converting those values into factors so that we can get a summary out of it. Now after we have converted into factor and 0 and 1 form. Let's check the values again and you will be able to see the output. So you see the levels have been changed to 0 and 1 here. Now let's combine the variable with the column, predicted column in our test data set so that we know what we can compare actual and predicted values. For that I'm using cbind, giving the name of the data set and then the column, and let's check the values.